Hey everyone, in this video I'm going to extend the system that we started on in the previous one so that we can switch between 4 different strafing, locomotion, looping, jogging animations. There isn't really much more to say, so let's get into it. To facilitate switching between different directional animations, I'll create a variable that can store our current direction in a more abstract manner than the locomotion angle, where each direction that this variable is capable of storing corresponds with an animation that we'd wish to play. There's a type in Unreal Engine that is well suited to this task called the Enumeration. I will create one now under the Blueprint section of the Create Asset menu. I will name it E_Locomotion Directions. I will open it up, and an enumeration at the most basic level is a list of named integers, where on our end we only see and deal with the names. Each of these named integers is called an enumerator, and I will create 4 of them now. I will name the first one F for forwards, the second one B for backwards, the third one R for right, and the fourth one L for left. That's it for this enumerator. I'll save and close out of it. Now, if I create a variable, name it Locomotion Direction, and if I go over into this type menu and search E_Locomotion, here we can see the Locomotion Directions enumerator that I've just created. Now there is a second one here. However, this is just from some previous testing and I haven't deleted it out of the project. You should only have one if you are following along. I'll select the one that I just created, and if I drag it out, we can access it and use it as an input into a new type of blend node. If I right-click into the graph and search blend by, you see there are quite many options. That's because a blend poses by enumeration node is created for each enumerator we have access to. I will search locomotion direction, and here we have blend poses E_Locomotion Directions. I will click it, and I'll go ahead and delete the old blend poses by bool as well as the logic we had wired into it from the previous video. Now you'll notice that our enumerators are not listed here in this node, and that isn't anything to worry about. If we right click, we can add them onto the node here. However, I'm not going to add forward, only backwards, right, and left, because this default pose is already on the node, and the top value is the default, and so having forward as well as default pose as inputs would just be redundant. So I'll plug in the forward animation and the backward animation that we placed into the graph in a previous video, as well as this locomotion direction enumeration. Now I'm going to go ahead and add animations for moving right and left, but first I'm going to briefly go over some details on the UUS locomotion animation set, which is what I'm using for this series. I'll go ahead and search jog loop, and here there are a variety of animations. I'll go ahead and open this left forwards animation here, which is using an abbreviation of LF, and the reason it is named left forwards is because the hips face forwards into motion. There is a left backwards where the character is moving in the same direction, but the hips are facing backwards into motion. Not many animation packs on the marketplace that I'm aware of have this amount of coverage for strafing, and I will be showing you how to make use of it soon in this series. For the time being though, I'm going to use the left backward 90-degree animation and the right forward 90-degree animation from this pack. I'm going to make sure that both of these are looping, as when an animation is dragged into a graph from this content browser here, it does not loop by default. I'm not sure why that is. I'll go ahead and set the blend times here to 0.3. And I'll go ahead and set the mode to Hermite cubic in out. Now that we have our logic set up for switching between animations, we need to actually set our locomotion direction variable. I'll create a function to perform that task. I'll name the function calculate locomotion direction. It will take in our current locomotion angle as an input, which is a float. It will also take in our current direction, which will be the type of our enumeration. Now, there are some settings that this function will take in as inputs as well. Instead of adding each of them as individual inputs, I will group them together to plug them in as one input. That way we can store our settings, if we wish, later on in a variable. To do this, I will right-click in the content drawer, and under the blueprint menu, I will select the structure asset type to create a structure. I will name it F_locomotion direction settings. This struct is a new type that can contain multiple variables, which we can set and access the same way we would set and access any other variable type. I'll create 4 float members of this struct. The first will be a F_min float, which will be our minimum forward angle, and an F_max float, which will be our maximum forward angle. When the character's locomotion angle is between these two values, the character will be considered to be moving forwards. I'll create a B_min and a B_max as well. This will be our minimum backwards angle and our maximum backwards angle. Anytime the character's locomotion angle is less than our minimum backwards angle or greater than our maximum backwards angle, the character will be considered to be moving backwards. This is because the locomotion angle, as I've mentioned in the previous video, is on a range of -180 to +180 degrees, where both negative and +180 correspond with the backwards direction. We can determine our right and left locomotion angle thresholds based on these two ranges, and we don't need to provide them. However, I will go ahead and create a dead zone float as well. I can save and close out of this struct, as those are all the settings we currently need. I'll add an input into our function, and for the type, I will search F_locomotion direction settings. Again, there's 2, but that's because I was doing some testing previous to recording this video. I'll name the input settings, and now I'm going to do the simplest bit of logic first, which is determining the direction regardless of dead zone. Then I'll go back and incorporate the dead zone logic later. I'll create a sequence node, as we will eventually be processing our dead zone logic before the logic I'm going to show you now. I'll create a branch and plug in our second execution pin of our sequence node into it. I'll go ahead and get our current locomotion angle input. I'm going to drag out from it and search in range. For the minimum value, I'm going to get our settings input, and I'll need to scroll down to the bottom here to get to it. I'll split the struct pin and plug in the forward minimum and forward maximum values. And I'll go ahead and plug this into our branch. Now, I actually made a slight oversight. I'm going to disconnect this branch and move this logic down. And I'm going to duplicate the whole thing. We need to check one condition first, and that is our backwards condition. That is because if we are within the range of backwards min to backwards mat, that means that we are moving in any direction except for backwards. So I'm going to check if we're within this range first and invert our return value with a not Boolean node. That means if the character is not within this range, we will return our true and output the backwards direction. And once we know that we are not going backwards, we can check our other ranges as normal. Backwards just gets the special treatment because it exists at both ends of our locomotion angle range. I'll go ahead and create a return node now. I'll give it an output of the type locomotion direction, and I'll make sure it is set to backwards. Now I can plug in our forwards logic into the false of our backwards condition, and off the true of our forwards checking branch, I will return forwards, and out of the false, we now know that we are not moving either forwards or backwards. So in a third branch, I'm going to check if our current locomotion angle is less than 0. If that is true, then we will return left. If it is false, we will return right. These are the only two other directions we could be moving in. Left will always be a negative value, and right will always be a positive value, so we don't need more logic than that. I'll go ahead and go into Blueprint Thread Safe Update Animation. I'll place our new Calculate Locomotion Direction function. I will set our locomotion direction variable with the output, which I will go ahead and rename to return value because I forgot to give it a name previously. I will input our locomotion angle and locomotion direction, and I'll drag out from settings and I'll make a struct pin here. Now I'm going to go ahead and set some values that I've found to work well for the animations that I'm using. However, you may find that you prefer different values or that different values will work better for your animation set. I'll put -50 in for the forward minimum, 50 in for the forward maximum, -130 in for the backwards minimum, and 130 in for the backwards maximum, with a dead zone of 20 degrees. I'll go ahead and compile this. Now I'll go ahead and go back into the cycle state and bypass our orientation warping so that we can see the animations that are being played. If I move backwards, we can play the backwards animation, play the forwards animation and moving forwards. We're moving left with left and right with right, so our directional logic is working properly, and we're switching between the 4 direction animations. Now, because our orientation warping node is in graph mode, it can go after all of our animations here, and it will read the data of the input pose and update itself accordingly. I'll compile, and now the orientation warping works as it should be with all of our directional animations. If I go ahead and play again, I'm going to move my camera back and forth, and as you can see, we still have some issues with the character wanting to really quickly switch its legs around with some relatively slight camera motion. While we can't fix this completely by adding a dead zone, we can limit this behavior. Back in the Calculate Locomotion Direction function, I'm going to go ahead and grab our current direction input. From it, I'm going to drag out and search switch. Here I have a switch node, which will fire off a different execution pin based on our current direction. I'll plug this into the first execution pin of our sequence node. I'm going to give myself a bit more space here between it and the other logic inside of this function, and I'm going to go ahead and copy these 4 return nodes. I'll organize them off to the side over here, and I'll go ahead and copy one of these in-range nodes as well, along with the nodes that we have plugged into it. What I'm going to do now is either add or subtract the dead zone setting from the minimum and maximum angle that I'm providing to the in-range node. This way, when we are checking if we are still within our current direction, we apply the dead zone to the range of our direction. I'll go ahead and put a branch here and connect the true into a return node and the entry point into the forward execution pin on the switch node. I'll set the return value to forward, and I'll plug the result of this in-range node into the condition of this branch. Let's say that our forward minimum angle value is -45 degrees. Now this is just for the sake of having a number to use for an example. If we want to extend that range, we'd need to subtract our dead zone because the forward minimum angle is a negative value. So I'll drag out from it, get a subtract node, plug our dead zone into it, and plug that into the minimum value of the in-range node. I'll drag out from the max, get a addition node, plug that result into the max value of our node, and plug the dead zone in because our forward max is positive. To extend the range, we need to add our dead zone to it. I'm going to repeat this process for the other 3 directions. I'll copy all of these nodes and paste them below. I'll plug in the backwards execution pin to our new branch, and I'll change the return value of this return node to backwards and plug it in to the true pin of our branch. Now I'll go ahead and disconnect all the inputs from these addition and subtraction nodes. Now we're going to do the inverse for our backwards dead zone because we are checking if we are outside of the range rather than inside of it. So I'll go ahead and create a not boolean node here. So instead of increasing our range, we want to decrease our range for this direction. Because our backwards maximum is a positive value, to decrease it, I want to subtract our dead zone from it, and I'll do the inverse by adding to the minimum backwards angle. Now I'm going to disconnect both of these nodes from this in-range float and ensure that the addition node is plugged in to the minimum value and the subtraction node is plugged in to the maximum value. I will duplicate this grouping of nodes, plug the branch into the right execution pin, and change this return node to right. And I'm going to also make sure that this not boolean node is not between these 2 nodes. We now need to calculate our right angular range based on the forward range and backwards range that is provided in the settings struct. The minimum value of the right range is the maximum forward angle, and the maximum right range value is the maximum backwards angle. So to extend this rightward range, I'm going to subtract the dead zone from the maximum forward value and plug that into the minimum value. And I'm going to add the dead zone to the backwards maximum value and plug that in to the max range. Finally, we have our leftward direction. I'll copy and paste these nodes and plug the left execution pin into the branch. I'll again fully disconnect the addition and subtraction nodes, and I'll change the return node to left. Now for our left range, I'm going to subtract the dead zone from the minimum backwards angle and plug that into the minimum value. And I'm going to add our dead zone to the minimum forward angle and plug that into our maximum value. Now we have our dead zone calculations complete. I'll go ahead and compile this, save it, and before I play, I'm going to go back into the cycle state here. And I want to point out a setting on this orientation warping node, and that setting is the Locomotion angle delta threshold. This is the maximum warping that an orientation warping node will apply to any pose plugged into it. I'm going to put in a value of 135 degrees here. Momentarily, I'll show you what would happen if I'd put a value in of 180 degrees and why I'm not going to do that. I'll compile and play. Now, if I move right with a small amount of camera movement, we continue moving in the rightward direction. If I rotate quickly enough, we do switch directions around, but the dead zone is large enough to keep us mostly moving right as I move the camera back and forth. The same is true for the leftward direction. However, we still switch between backwards, forwards, left, and right properly when entering into a range that is not adjacent to one with a dead zone. So our dead zone seems to be working quite well. Now I'm going to go ahead and show you what would happen if I up this 135 degree setting to 180 degrees. I'll compile and play again. Now, as I pivot my directions, the character tries to rotate and change the orientation of the animation by 180 degrees, and we can see this rotation begin before we fully blend it into the next animation. If the orientation angle exceeds the limit we've placed, it instead applies the inverse. However, because no orientation angle exceeds a 180 degree limit, we get hips that rotate too far. It's a common problem, and again, the easiest way to solve it is to just make sure that your locomotion angle delta threshold is set properly so that when you switch directions, you're exceeding that threshold and it does not try to over-rotate the hips before you fully blend it out of the animation that is being warped. All right, everyone, that is going to be it for this video. If you have any questions, though, be sure to leave them in the comments or in the Discord server that is linked in the description below. I'll do my best to answer them in either of those two places or directly in the next video in this series. I'll see you there.